Well, hello everybody, and thanks to Mr. Mason for putting this up. Sorry I can't be there with you. It's better off that I'm at home right now, but I look forward to being back in class on Monday. So we're going to take a look at two questions from the work that Mr. DeLu did with you, specifically number 10 and number 11. And so I'd like you to pause right here and find that in your books, please, and then we'll start again right away. Alright, so the first question says, determine if the projectile will reach each height. We don't need to know when it reaches the height, we just need to know if. And that's a perfect question for using the discriminant. So the discriminant, as you saw with Mr. DeLu, is just the b squared minus 4ac part, the part under the root sign. If it's greater than 0, then we have two different roots, two different solutions. If it's equal to 0, we have two equal solutions. And if it's less than 0, if it's negative, we have no solutions. So let's see what happens in this case. So you'll see that I've put in the 2.75 kilometers in here, but I've changed it to 2,750. Why? Well, because in the question it says that the height was measured in meters. So we had to convert the 2.75 kilometers to 2,750 meters. And then I want to rewrite this equation so it's in the form ax squared plus bx plus c equals 0. So I'm going to end up moving this term over there, both of these terms over, so I end up with a positive 4.9t squared. So if that's the case, we get 4.9 t squared minus 250t plus 2,750 equal to 0, and we just plug that into this discriminant to see if we get something greater than or equal to 0. And when we check that out and plug it into the calculator, I get 8,600. So I've got something greater than 0, so that must mean it has two solutions. So from a graphical perspective, if that's the path of the flare or the projectile, it's going up and then coming back down, it's crossing that height at two different times, which is great. So we can answer A, if the projectile will reach this height, yes. So when you look at this one, we do the same thing, except that we've got 4,000. So I've got 4, just from here, 4.9 t squared minus 250t plus 4,000 for the 4,000 meters. And that comes out to negative 250. I'll just finish that off here. So negative 250 squared minus 4 times 4.9 times 4,000. And when you plug that into the equation, you get negative 1,500, or 15,900. So for sure, less than 0. So no solutions. So does it reach 4 kilometers? Well, that's kind of like the projectile going like this, and there's 4 kilometers. So no, it does not reach.